you look at the periodic table, barium is in group 2A, chlorine in group 7A. So the formula for barium chloride would be -1 times 2, 2 negative charges. Group 2A, 2 positive, no net charge. Okay, so this is something that we need you to get used to, because and when you learn a language there, you first learn the alphabet. Once you learn the alphabet, you have to be able to come up with spellings, and you have to be able to spell out words there. Okay, this is the correct spelling, the correct formula of compound there. Now, if you have aluminum oxide, okay, aluminum being group 3A elements, 3 positive charge, the formula for aluminum oxide would be Al2O3. Oxygen being group 6A, -2. So -2 times 3 gives you -6. Positive 3 times 2, positive 6. Positive 6, -6, no net charge. So this would be the correct formula for aluminum oxide. Okay, and then using the chloride ion is probably easier when we try to give you examples there. But there are ions that are going to bear more than 1 or 2 negative charges or positive charges. When you put them together, you have to be able to, you have to double check and make sure there is no net charge in the formula. Otherwise, the formula is incorrect. The spelling is wrong. Then there's a problem there. Okay. So what about the polyatomic ions? Well, so far we've been looking at monatomic ions: chloride ion, oxide ion, aluminum ion there. Now sometimes you may have more than one type of element clustered together. They form an ion that bears a charge. That's what we call the polyatomic ion there. So using phosphate as an example, if you have a phosphate ion, you have 1 phosphorus atom in it. You have 4 oxygen atoms in it. This group stays together. They bear 3 negative charge. Now, if you form a magnesium phosphate, the correct formula for magnesium phosphate would be Mg with the number subscript 3. PO4 is polyatomic ion. We put them in the parentheses. Since it bears 3 negative charges, we have to have 2 of them. Just like the aluminum oxide, Al2O3. Okay? The net charge has to be 0. Okay? So for polyatomic ions, you need to know their charges so that you can write out the correct formula. Now this is a little bit, probably rushed a little bit here in giving you the polyatomic ion. I don't know, I probably should have done this particular slide first before we ask you to write out the formula for the polyatomic ions there. And so polyatomic ions, again, polyatomic ions are the ions with more than 1 type of atom. They can bear positive charge, they can also bear negative charge. And this is commonly known ion there, carbonate ion, CO3, 1 carbon, 3 oxygen. They stay together as one group. You don't break them apart. Okay? When you dissolve, say, baking soda, sodium carbonate. If you put them in water there, you have sodium ion, you have carbonate ion. Carbonate ion is an anion. It bears 2 negative charge. Ammonium ion, NH4+, can bear 1 positive charge. So polyatomic ions can be positive or negative. It depends on the atoms that we have in there. Okay? So in this case, if we have, say, nitrite ion, NO2 minus, and we ask you to write out the compound, formula for compound with polyatomic ions there. Sodium nitrite. What's going to be the formula for sodium nitrite? Oh, we know sodium is group 1A, 1 positive charge. Nitrite ion, 1 negative charge. So the formula would be NaNO2, 1 positive, 1 negative. How about barium nitride? Barium group 2A elements. NO2 bears 1 negative charge. So the formula for barium nitride would be what else do we need?
Parentheses and then 2 of those.
Okay, so again, when we ask you to spell out chemistry word, you have to check the charges there. Once you have the word spelled out, you have to make sure there is no net charge in that formula. And if you just do BaNO2, there is one positive net charge in there. It's not correct. You have to put a 2 in there. So the numbers are being used, the subscript numbers are being used to balance the positive charge and negative charges there. Okay, so let's do an example, do practice here.